This video is about analyzing piecewise functions from a graph, analyzing piecewise functions from a function definition, and graphing piecewise functions. So piecewise functions are functions that look like they are broken into pieces with different parts of the line in different sections of the coordinate plane. So does number one represent a function? Well, if we do the vertical line test and we roll our pencil over the graph, or we just start drawing vertical lines, each vertical line is only touching one point. Even here with the 3 dots, only one of them is solid, so it's still passing the vertical line test. So because this passes the vertical line test, this graph is a function. So we would say yes, because it passes the vertical line test. So with a piecewise function, sometimes there are going to be multiple dots with the same x-coordinate. However, the graph is going to be a function if only one of these dots is closed, and the rest of the dots will be open. So when we were asked to find f of x, your answer should only be the y-coordinate of the closed dot. So let's practice finding some f of x values. Using the graph below, find the given values. So we have f of -5. Well, at -5, there's 2 dots. There's an open dot and a closed dot. Remember that we want the y-coordinate of the closed dot. So the closed dot is down here with a y-coordinate of -4. The next point is f of 2. So here's 2, again with an open and a closed dot. So we want the coordinate of the closed dot, which is 1. F of 4. F of 4 is on this horizontal line, so we want the y-coordinate of where that graph is. So again, we are at 4. F of -8. So -8 is over here. It intersects with the graph at this point, which would be 6. F of 0. So remember, f of 0 is on the y-axis. So we are crossing with the line going through the origin. So our y-coordinate would be 0. F of 6. So the last one then is f of 6. Well, we don't have 6 on our graph, but we know 6 would be somewhere over here. And because it's a horizontal line for the graph, we can still determine our y value, which is going to be 4. So the reason that we can again determine this is because the graph is a horizontal line. So even though -6 is on there, we know it's forever going to be a horizontal line. So no matter where 6 is, the y value is going to be continuing to be 4 all the way to infinity. So when a function is not increasing or decreasing, we're going to say it's constant. This is going to happen when we have lines that are horizontal. So just like when we had 0 slopes before, that's a constant slope because it's staying the same. It's not changing and going higher with values or going lower with values. It's staying at the same value. So let's use this graph to answer some more questions. So as x approaches infinity, remember that that is our right arrow. F of x is approaching. Now because it's a horizontal line, the y value is never going to change. It's going to continue to stay at 4. Then when we have as x approaches negative infinity, we have our arrow and it's pointing up. So in this case, that means f of x is going to approach infinity because our y values are going to continue to get bigger and bigger in the positive direction. How many zeros does this graph have? Well, to have a 0, you have to cross the x-axis. So if this is our x-axis, we are crossing in one place. So we would have 1, 0, which would be at the point 0, 0. Then it says, is the function increasing, decreasing, or constant over the interval? So the first interval is -infinity to -5. So from -infinity to -5, the line is going down. So in this case, we are decreasing. The next function that we have is -5 to 2. So from -5 to 2, this time the line is going up. So we are increasing. And the last part is from 2 to infinity. So from 2 to infinity, this is a horizontal line. Remember, horizontal lines are always going to be constant. So we can also find the f of x value without a graph when we use the function rule. Make sure that when you are plugging in your x value, it's using the correct equation using the given inequality. So we have two equations with two inequalities. The first equation is 5x minus 4 when x is less than -1. And the second one is -2x plus 2 when x is greater than or equal to -1. So we need to pay attention to our f of x value. So in the first one, our f of x value is -5. So we need to look at the inequality. Well, here -1 is less than 1, and that's true. So we're going to use the first equation to find our value. So we're going to do 5 times -4 minus 4. Well, 5 times -4 is -25, minus 4 is -29. The next one is f of -1. Well, if I go to put -1 into the first inequality, -1 is not less than -1. But in the second inequality, -1 is greater than or equal to -1 is true. So we're going to use this equation to find our value. So we're going to substitute -1 in for x. So -2 times -1 plus 2. -2 times 1 is 2 plus 2, which gets us 4. The next one, f of -10. So -10 is less than -1. So again, we're going to use our first equation. So we have 5 times -10 minus 4. 5 times -10 is -50. Minus 4 gets us -54. The last one we have is f of 0. Well, f of 0 is greater than or equal to -1. So we're going to use our second equation. So the second equation, we would have -2 times 0 plus 2. -2 times 0 is 0, plus 2 gets us 2. So this would be equal to 2. Number 18, f of -3. So -3 is less than -1. So we would have 5 times -3 minus 4, which would give us -15 minus 4. So we would get -19. And then our last value, f of 5. 5 is greater than or equal to -1. So we're going to use the second equation. -2 times 5 plus 2 equals -10 plus 2, which equals -8. Let's try another example where there's now 3 equations. So the first equation, we have 3 times the absolute value of x minus 1 plus 4 when x is less than or equal to -4. We have -7 plus x when x is greater than -4 but less than -3. And we have 13 when x is greater than 3. So the first value we have is f is -11. Well, -11 is less than -4, so we're going to use the first equation. So in that equation, we have 3 times the absolute value of 11 minus 1 plus 4. Well, the absolute value of -11 minus 1 is -12. The absolute value, that is +12. We have 3 times 12 plus 4. 3 times 12 is 36, plus 4 gets us 40. The next f of x we have is -6. Well, -6 is also less than -4, so we're going to use that same equation. 3 times the absolute value of -6 minus 1 plus 4. Well, -6 minus 1 is -7. The absolute value is 7. We have 3 times 7 plus 4. 3 times 7 is 21, plus 4 gets us 25. The next equation, f of -4. Well, notice there's a -4 here and a -4 here. Well, this time it's -4, so we need to be less than or equal to -4. So we still want to use the first equation because there's a bar underneath it, which means x is less than or equal to -4. So we would have 3 times times absolute value of negative 4 minus 1 plus 4. So negative 4 minus 1 is negative 5. The absolute value of that is positive 5. So we have 3 times 5, which is 15, plus 4 is 19. The next value is f of 0. Well, 0 is not less than negative 4, so we need to find the new inequality that's going to fit in. The next one is meaning that x is between negative 4 and 3, or equal to 3. Well, 0 is between those two numbers, so we would be using that equation. We have negative times 0 plus 7. So 7 would be our value. F of 3. Well, we want to know where x is equal to 3, and in this second inequality, x is less than or equal to 3, so we're going to use that equation. So negative parentheses 3 plus 7 gets us negative 3 plus 7, which is 4. And then our last one, f of 18. Well, 18 is not less than 3, so we need to move to a new inequality. 18 is greater than 3, so we're going to use the third inequality. Now, the third equation does not have an x value, it just has 13. So it means that no matter what, our y coordinate is going to be 13. So in this case, all we do is put 13.